The CT ratio can still indicate the correct temperature, even if the view between the sensor and the object is compromised significantly. We can demonstrate this here with a small experiment. I have a matrix of grid structures here, and we will set various grid structures between the sensor and our measurement object, which represents the black body radiator. At present, we have a direct view between the sensor and the black body radiator, and you can see in the Ratio Connect software that both temperatures, the ratio temperature and the one-channel temperature, indicate the same value. The attenuation here is 0%. Let's now move our first grid structure between sensor head and black body radiator, and find that we already have a 48% attenuation here. The ratio temperature is still correctly displayed at 883 degrees, but the one-channel temperature has gone down a little, now 824 degrees. Let's look at the next grid structure. Here we have an attenuation of 69%, and the ratio temperature is still displayed correctly. Let's choose a closer grid structure. We have an attenuation of 88%, and here too our ratio temperature is still displayed correctly. The one-channel temperature, as we can see here, has clearly reduced down to 712 degrees. In the last grid structure, the grid gaps are so close to that, we now receive a 96% attenuation. You see that here our quotient ratio temperature has also fallen correspondingly to the starting temperature, and that it is no longer indicative of the correct value. Up to an attenuation of 95%, we have the possibility to present the correct object temperature. For example, even in poor visibility conditions, with an attenuation of up to 95%, our CT ratio still shows the right temperature.